Homogeneous differential equations are of the form dy by dx equal to a function of x and y, which can be expressed as a function of purely y by x terms. If an equation can be expressed only in terms of y by x, then the method would be to substitute for y by x equal to v and then differentiate it to get dy by dx. Now let's come to a problem and find out whether it is a homogeneous equation without actually going through this process. If we go through the process, then the method would be to find dy by dx as a function of x and y, and then we divide each term by x squared in the numerator as well as the denominator to get 1 minus y by x plus y by x whole squared over y by x. Every single unknown here is a function of y by x. We don't have any x term separate or y term separate, only y by x terms and perhaps constants. Now when you get it in this form, we know that it is a homogeneous equation. But even without this, if you look at each term, if you look at x squared, the degree is 2. If you look at xy, the degree of x is 1 plus degree of y is 1, 1 plus 1 is 2. Degree of y squared is also 2. Degree of xy is also 2. If every single term has the same degree, then we say it is a homogeneous function, and in this case it is of degree 2. Otherwise, if you write it as dy by dx equal to function of y by x, then it makes our work simpler because all we have to do is substitute y by x equal to v. Now when we do that, we have already found out that dy by dx is equal to x dv by dx plus v. Now we have to solve the problem by separating the variables. There are two variables, x and v. So from this we get x dv by dx is equal to this term minus v. So you get 1 minus v plus v squared, and then this becomes minus v squared, which gets cancelled, and so you get 1 minus v by v, and this can be separated as v by 1 minus v dv is equal to dx by x. Now we have come to the first type where you have v terms separated from the x terms. So the method for variable separable is just integrate and write down the answer. So now the next step is to integrate this expression. Integrating, we get integral of v divided by 1 minus v dv is equal to integral dx by x plus a constant c. Constant c is the constant of integration. As always, we add the constant c. Now to integrate, whenever the degree of the numerator, the variable in the numerator v, is the same as the degree of the variable in the denominator, in such a case we try to make the numerator in terms of the denominator. So first of all, we can multiply by minus into minus. There is no change in the expression, and we can rewrite this as 1 minus v. That means we have added 1. If you add 1, you should also subtract 1. In the right hand side, the differential of x is equal to 1, so we know that the integral is log x. Also we can learn it as a formula, integral of 1 by x is log x. Now here we separate it into two terms so that we get minus integral 1 minus 1 over 1 minus v dv is equal to, the right hand side remains the same. Now integrating this, we get minus v. Now the integral of the second term is log 1 minus v, but because there is a minus sign outside, we get minus log 1 minus v equal to log x plus c. Now this is the final answer, except that we substitute back for v. Whenever we make a substitution, we must remember to substitute back for the original terms. V is equal to y by x. So you have So this would be the answer, except that when you present it for an examination, it would always be better to take the LCM and present it in a neater manner. But this finally is the answer for the problem.